Richness, depth, and diversity are hallmarks of Dan Linehan's career. He has at one time been a scientific researcher, a microchip process engineer, a writer and producer at a leading film studio, managing editor of a literary journal, and a science expert for leading educational publishers, to name but a few. He has authored well over 100 publications and widely lectures at schools and universities, space and science centers, and other intriguing venues. I first met Dan when he was working locally at Sea Studios, repurposing the story of Otter 501 for web and multimedia presentation. Otter 501 tells the story of the 501st otter to be rescued, rehabilitated, and released back into the wild by the Monterey Bay Aquarium. It was purposely given that name to keep the trainers and handlers from bonding with her and making her reliant on their care. Rather, 501 became part of a novel surrogate program whereby she was introduced to an adoptive sea otter mother who reared her and taught her the survival skills necessary for re-entry into the wild. Dan's most recent work, The Princess of the Bottom of the World, chronicles his travels to Antarctica and other remote regions to study the complicated scientific issues that severely affect our planet. His approach was greatly inspired by Carl Sagan's Cosmos and in his use of fiction by John Steinbeck to make significant environmental issues more approachable for a general audience. Today, he will be sharing with us his thoughts on the current disconnect between what is real science and what is not, why it is hard for people to accept the inconvenient truths of science, and how to bridge the many misinformation gaps. But before turning over to Dan, I want to leave you with my holiday wish. May your troubles be less, may your blessings be more, and may nothing but happiness come through your door. Dan, the floor is yours.
Thanks again, Brooks, for that really kind introduction and also for inviting me to talk with you. And so what I figure I'll do is cover a lot of the issues that have kind of been real important to me and shaped my path as I transitioned from being a scientist engineer to a writer covering these topics. And so I titled this presentation as Stories of Fire and Ice and then Strategic and Effective Communication on Science Challenges. I moved out to the Monterey area to do my first job in '95. So I'll probably share with you guys some things that are kind of close to me, but also should be close to you as we're kind of, in the same area. You guys mentioned Antarctica, so I will kind of hit a couple of these quick facts to support this little story that I'm going to be kind of covering. So obviously, I think we know that Antarctica is the coldest place in the world. We've seen enough documentaries, but it's also the windiest place in the world. The other thing is that you might not realize it's the driest place in the world when you consider the amounts of precipitation. And that's a real, it's not an obvious thing, but it's so darn cold, there's almost no moisture in the air for actual precipitation to happen. So it is really the biggest desert in the world. It's covered in ice and its average is about 1.5 miles thick. And then at its thickest, it's about 3 miles. There are no terrestrial mammals that are natural to Antarctica. There are absolutely no polar bears in Antarctica. And there are no penguins in the Arctic. Okay, so these two never cross except for cola commercials or such that make it difficult for us science communicators to actually keep facts straight. So these two species never mix. Interesting on the size, though, Antarctica is about 1.5 times the size of the US. It's the 5th largest continent. Just like the Arctic, you've got the seasonal sea ice that goes back and forth. It almost doubles in size in the wintertime when the sea ice is forming. And when it does, it becomes the 3rd largest continent. But without any permanent ice, it would be the smallest. This is another interesting thing about the Arctic versus the Antarctic. Antarctica is an actual continent and it's surrounded by ocean, but the Arctic is actually ocean surrounded by continents. Very, very different. So when we hear about the melting of the sea ice in the Arctic versus the melting of the ice in Antarctica, it's very, very different physical processes that are happening. So there's quite a big difference. Another interesting thing is the Southern Ocean is bounded by, 60 degrees south latitude, and that surrounds Antarctica. And this is really where the biggest waves on the planet are, especially in this little section called the Drake Passage right over here, which is where the Antarctic Peninsula is over here. And this is the tip of South America. I hope you guys can see my pointer. And believe it or not, this distance right here, it's actually shorter than the distance between Northern California border and the Southern California border. So that's quite amazing. I don't think a lot of people recognize that. So I'm going to jump off with the Antarctic Peninsula. As I mentioned, it's about 620 miles from the tip of South America. And this kind of really leads me into what Brooks had mentioned is this question of why is it so hard for so many people to accept science that's inconvenient to them, but ultimately beneficial? And I really shifted my career to focus on trying to deal with this in many, many, many different ways. And so you'll see quite a few in this presentation that I give. So I kind of want to start off by just talking about a little bit about climate science. So this is really what drove me to get to Antarctica. And there's some really fundamental physical things that if people stop to think about, it would be very clear. For example, our atmosphere is really thin. It's really like having plastic wrapped around a basketball. That's about really the size relation to it. So whenever we have all these things about how can climate change by people, it's impossible. Well, the reality is our atmosphere is really thin. And the other thing too is it's actually mostly nitrogen with about 20% oxygen in, and the rest are these other gases such as CO2 and other greenhouse gases. So those changes in concentration, just minimal, can really impact the balance of our atmosphere. This is an image I got from NASA, and I kind of dressed it up a little bit. So what I want to do is I just want to show you again where things are happening and how close they're happening to us. So I put a couple of the layers of the atmosphere on. The troposphere is where we're at. The stratosphere, everybody kind of has probably heard about the stratosphere. But then you have the mesosphere and the thermosphere and the exosphere as you get further and further up. But the interesting to note is the start of space is only 62 miles, right? This is where space starts, right? That is really, really close to Earth, relatively speaking, right? And then you could see over here, we have the ozone layer is in the stratosphere. But the interesting thing to really keep in mind is that most of the mass of the atmosphere is in the first 5 to 9 miles above surface of the Earth.
And can I ask a quick question?
Sure.
How do you define start of space?
Start of space. So start of space is actually kind of operationally defined, and most people take it as the Kármán line, which is 100 kilometers. And that's what scientists kind of have used is like there's a big difference between the physical properties of the atmosphere. So most of these layers like troposphere, stratosphere, they're not just made up lines, there's physical properties that actually change. And so these are kind of like the boundaries of the atmosphere based upon changes of physical properties. And so operationally, it's 100 kilometers is the Kármán line. I know astronauts, I think the military uses 50 miles to give astronauts wings. But commercially, the commercial astronauts and the NASA astronauts, they go by 100 kilometers or about a little more than 62 miles. So going back to, again, this thing about the mass. So most of the mass of the atmosphere is in this small little area. This is where the airliners fly because airplanes need actually atmosphere to have lift. If it's space, they can't fly, right? This is where our weather is. And again, this is where the greenhouse effect is occurring. So again, to put it into context about the size of what 5 to 9 miles is. So if you were to stand on Point Pinos and look across to Point Santa Cruz, right? That's a little more than 22 miles. So here is to show you the boundaries of what our troposphere, where most of our atmosphere is. So if you imagine standing on Point Pinos and looking 9 miles, you can only see a little past the edge of Marina. Now, the lower limit of the atmosphere sometimes, and that depends on the geometry and in geography and other properties of Earth, sometimes the limit is 5 miles. So you can barely see into Seaside if you were standing on on Point Pinos. So that kind of gives you an idea how small of an area we're working with when we're talking about dumping 152 million tons of greenhouse gas every 24 hours into the atmosphere. That is an awful lot of material to be putting into a really relatively small space. And you know, we've identified problems in the past that were atmospheric, and we've put solutions in place, like the hole in the ozone layer. So we started to put solutions into place, and you could see when we started to detect the hole in the ozone layer, now there's chemical processes that are still going on. We started to get the hole in the ozone layer recovering, and you could see from the modeling now, this is the path that we've got, and eventually we're going to get back to normal if we continue doing the solutions that we've put into place. What about acid rain, for example? Another atmospheric problem that we had emissions of sulfur oxides and nitrous oxides. They'd reach the clouds. They would chemically react to form actual acids. These acids would then precipitate as snow and fog and rain, and then they would destroy the wildlife, the infrastructure, the trees, all that stuff. I'm from back east. This was a really big problem at one point in time, but we put solutions into place. We curbed emissions, and that led to recovery. And even smog, for some of you who have been down in LA, you know that it used to be horrible. There were many, many smog days. Now, this is a really interesting graph because what it shows is when they put solutions into place to curb emissions with cars, you had more smog and it drastically dropped. But the other thing too you notice is there's more and more cars. So you actually have more cars on the road with less smog. That was done by putting solutions into place, and it fixed an atmospheric problem. So let's take a look at some trend comparisons. Let's take a look at emissions, for example. We're burning all this fuel. We obviously see our emissions are increasing, right? This is just a fact. This is real data, right? So if we were actually increasing all this emissions, we should expect to see more and more of these gases, these emissions into our atmosphere, which is, we obviously see that. So if we see this trend of more and more of these greenhouse gases, and the science behind the greenhouse effect is about 200 years old, it's very simple science, we would expect the temperature to increase. And we see that. We see this track extremely close to how the changes in the trends in emissions have tracked. So if we're getting the Earth a lot warmer, what other physical things would we expect, right? Well, would we expect the sea level to go down or up? Well, we know if we heat stuff, it expands. So we know that there's expansion happening in the sea level, but we also know a lot of ice is melting, right? Because of the heat. So the data shows, again, sea level is rising. All of these trends are physics. They're all tied together by the basic laws of physics. They're all going in the way they're supposed to be going. Nothing is going in the wrong way. And these are just a few of these trends. You also hear a lot of times about, oh, periodic cycles, there's nature. Well, I'm going to show you this graph over here, and you can see that this is a graph that is from starting at the 0 mark, which is 1950, and it goes all the way out to 400,000 years ago, and this is carbon dioxide measured in the atmosphere. So you can see from this little section that I put out that you have definitely a trend showing here. We have a downward trend. It shows actually carbon dioxide is dropping during this period. It's a difference of 95 parts per million. But when you open up this range a little bit, you see that yes, indeed, we have a cyclical nature. Absolutely, there's nothing, these are the glacial periods that people talk about. That is cyclical. But if you notice over from this period of time, it's over 375,000 years, the difference between the maximum and minimum has only been at 120 parts per million. So let's kind of take a look at, we'll expand it a little bit, and you can see from our trend that we saw going down, well, now we see something starting to go up. Now, this can look natural. This can definitely fits into the pattern over here, but we have to look more closely to what's happening currently. So what is the current concentration? So we go to take a look at NASA. This is measured very, very closely. We're currently at 415 parts per million. And this shows since 2005, this is a difference of 37 parts per million in only 15 years. So what does this look like compared to the graph I just showed you? Well, let's put that data on, and we see that in December of this year, we're at 415 parts per million, and look at how much we've jumped. This is no longer cyclical. This is a trend. This is a trend that is very different. It is outside of anything natural, okay? So let's even take it a little bit longer. Let's say 800,000 years, right? We just doubled it, 800,000 years. Again, glacial periods. We never get higher than 300 parts per million up until the 1850s. Our difference is 125 parts per million. In this small 100-year period between 1850 and 1950, we jumped 30 parts per million to a number we've never seen before. In the next 70 years, we've increased over 100 parts per million in just 70 years to a level that is higher than ever seen on our planet in 800,000 years, not natural. So again, you take a look at the science, we know it's thin, we know we're dumping a lot of CO2 in, we know that we've come across atmospheric problems and we solved them before, simple physics and simple chemistry. We know that trends obey the laws of physics, and we know that climate change is not natural. So why is this still such a difficult thing for people to get behind? So now I'm going to jump back to kind of, Brooks already told you about a little bit of my background. I started as a scientist and an engineer. This is me working in Salinas. There used to be a microchip company there. But, you know, I really kind of started to get involved in writing a little bit before this. So my first publications were actually in grad school. My research was funded by the Department of Energy, and I used to use lasers to make superconductors, right? And then I would analyze them with electron beams and atomic forces and all kinds of crazy things like that. And I got my first paper, and I was a researcher there, but I got more and more interested in things as I was writing my thesis. I really, really liked the writing process. I really liked how to communicate science. And in fact, this is a model of the superconductor. It's called YBCO. And I ended up drawing this for my thesis, and I really just loved just to communicate things. But I tell you, back then, I really didn't know much about the environment still, and I really wasn't quite sure about, you know, the problems that really face people once they leave college, the realities. So an interesting thing, though, again, this is a poem that I wrote on and I put it on my first page of my thesis, and this is also creative writing, right? So I started to get interested in that. And then eventually this poem ended up getting published in the Monterey Bay, the Monterey Post, the old newspaper. But as I was an engineer still, I was really inspired by the X-Files. So as I'm taking as many classes as possible, I wrote a screenplay that I submitted to the X-Files, and they sent it back saying, you know, we didn't read it, we don't really want to hear from you. But I was really inspired to keep writing. And so again, this is all while I was an engineer. We were coming up to the Y2K, and it was a really big problem for a lot of technical companies. And so I was charged with making sure that certain things in the fab were working okay and they didn't create problems. So I wrote an op-ed piece in the Californian, but then I wrote some speculative fiction about what could possibly happen a couple months before it happened. And so this is one of my first paying gigs as a writer. I quit in 2000, and I took about as many classes as I could take. I even took journalism in Hartnell. This is my first journalism article ever. I wrote about a diversity conference. But really, what paid the bills for me is working with educational companies, you know, as a science editor. So I worked, you know, with getting all these publishing skills really helped me learn how to communicate science a little better. But really, it wasn't until 2002 when the Larsen B ice shelf disintegrated. Now, remember, I showed you guys that picture of Antarctica. I showed you the Antarctic Peninsula. This occurred in 2002, and it really hit me like a ton of bricks. because I'm like, this is not normal. 1,255 square miles. It's 6 times larger than the Monterey Bay if you bound it by Point Pinos and Point Santa Cruz, right? And it disintegrated in 35 days. I'm like, whoa, that does not seem normal. And it turned out that Antarctica was heating up faster than any other place on Earth, and that has to do with certain the geophysical properties of the poles. So I'm like, wow, this is something really serious, and it really changed the direction of my work. But I still had to build up my writing skills. So I wrote a lot for the weekly. I did a lot more, again, poetry and all kinds of other creative writing, anything to build the actual skills you need to kind of tell stories. But really, for me, the biggest break was I was in this office, right, where you see right now, working on food webs for fourth graders or fifth graders, and all of a sudden, I heard on the radio from the Santa Cruz radio station at the college up there, there was a PSA, there was a benefit for the Santa Cruz SPCA ran by the Cheese Ecology Safaris, which is this really great company that does these super high-level scientific and ecological tours. And so I was able to go with these guys to figure out how to get to Antarctica, because back then it was really difficult to get to Antarctica. And so I started off in Ushuaia. I then moved to the Falklands, then to South Georgia, South Orkneys, Antarctica. I'd come back to Argentina. I'd spend some time in El Calafate, where that's Patagonia, where they've got some glaciers. I'd go to Iguazu, and then I'd take off from Buenos Aires. That was the plan. I was going to write nonfiction about climate change. And I was all set to go. So this is an interesting photograph from my ship. This is the radar screen, and every green dot is an iceberg. So that is kind of a fascinating thing when you're thinking about, you know, taking a journey like this. You can see them up a little bit closer. And so our ship was able to hit certain icebergs and not sink, but there was a limit. So I reached over in this particular photograph to take a photo of the bow, and you can see kind of the shape of everything. And then on the photograph on the right-hand side, you can see it's about to strike an iceberg. And we did. We hit some icebergs. And the first time you hit an iceberg, it's really jarring, let's say, and especially if people aren't ready for it. But when I started to visit places like, you know, South Georgia and, you know, Antarctica, I really got to see the absolute effects of climate change and environmental issues, which is what I was there to study. So this is a glacier in South Georgia. Decades ago, this glacier reached all the way to the ocean, or to the bay, I should say, behind I would say to the left of the mountains I'm pointing to here. I mean, it's just massive amounts of retreat that went on here. Those are king penguins in the background. Again, a common sight, you know, are tabular icebergs. Some could be many, many miles in size, floating by. This is a glacier that I hiked up to the top of a glacier and looked down at the crevasses. This is calving that's happening. This is an interesting photograph. This is actually the expedition leader of my journey. And we're hiking up a glacier in Antarctica, and it's so hot, he's not wearing a shirt. That's how hot it was. And encountering types of things like that were just so far away. I think what I wanted to do was, how can I capture things that are happening like this so far away and bring them home and see how they connect to us? So here's an example. Factory fishing, you know, we're in Monterey, we've got some fishing, but we also have issues sometimes with overfishing. And out there, it was like the Wild West. Few regulations, essentially, no enforcement, and people can just essentially do anything. And they've got giant ships just clear cutting everything. It's not sustainable. It's so hot that this penguin here is panting from the heat because it's got down feathers. It can't go into the water yet. It's got to grow normal feathers before it can actually go into the water. So these animals aren't used to such high temperatures. Invasive species was a problem when I was there. You've got reindeer introduced. They have no natural predator, so they just, trample over everything. These were recently eradicated to restore the balance of the environment, but invasive species is a problem that we face here. And whaling still is occurring in Antarctica, and it was impossible to go anywhere without seeing whale bones, and it was everywhere. These skulls are from blue whales. And then plastic pollution. We saw plastic wash up on shores in the most remote places. And again, this is entanglement. Again, with few regulations, what they do is if there's garbage, they just toss it in the ocean. And this seal essentially got snagged in a net. And as it grows, it will die. And there's just nothing you could do about it. So this is a really interesting place. This is called Deception Island, and it's a caldera, and it's a C-shaped island that is the top of a volcano. And I show you this because this is the radar screen of it. And then over here is the opening to get into the middle of the island, because there's a great harbor, for protection from waves and weather and stuff like that. The only problem is it erupts every once in a while, and it's knocked out a bunch of bases. But this over here is the sister ship of another ship that actually struck rocks, right where I'm showing you over here. So it was charted rocks. It struck rocks. Basically, they claimed that it was not a problem. The reason why I'm telling you about this is because it really changed the course of my work. So here's again that map of Antarctica. There's Deception Island where that ship hit the rocks. I was just there only a week previously. Again, you can see where Deception Island is on these maps. But I was already back in Argentina when I heard about the news. In fact, I was in Iguazu just getting ready to return. But instead of returning back to the United States, I flew back to the seaport and went on stakeout because I wanted to write about what happened. So here I am at the harbor waiting for the evacuees to come into the harbor so I can learn about what happened with the shipwreck. And I got a hotel room right across from the bay and was on stakeout. I was able to infiltrate the port and basically learn that indeed the ship ran aground and it basically leaked tons of oil everywhere on the pristine habitat and lied about it. And it got away with it. These are some of the challenges that we face. It's these big companies can easily lie about this stuff and there are no repercussions, but the scientific and the environmental damage is incalculable. So during that time, I discovered a real live princess. And so my original plan of 37 days turned to 63 days. And so what I did was I was still doing nonfiction in Argentina at that port. I was writing about what I saw in a journalistic and nonfiction way. But this is a quote from Steinbeck. It says, "The journey is a person in itself. No two are alike, and all plans, safeguards, policing, and coercion are fruitless. We find after years of struggle that we do not take a trip. A trip takes us," right? That's from Travels with Charlie. But the thing about Steinbeck is really when he wrote like Cannery Row and Grapes of Wrath, he was actually using backdrops of severe environmental issues. Cannery Row, overfishing. Grapes of Wrath, Dust Bowl, overfarming, poor farming practices. And then also Steinbeck got more and more involved in citizen science. So he became a pretty good inspiration for some of my work. Like Brooks had mentioned, it was, I think Steinbeck, Cosmos, and then I would say, I went to Antarctica around the time that Al Gore did An Inconvenient Truth. And so that was also very inspirational. And so I decided to then go fiction. But I had to come back to the United States because actually I had two paying gigs that were to write about these two space books. So I covered the new space race when Burt Rutan designed the spacecraft to go to space for Paul Allen, who basically funded the whole project. I did the two big books that covered that. And that kind of took me a little bit away from, my passion, but, you have to pay the bills, and the technology was very interesting to me also. But during this time, this ship, I took these photographs of it, this ship actually sank. This ship in Antarctica is now at the bottom of the ocean right now. This shows you how still challenging Antarctica is. So I figured that, again, fiction is the best way to do it, but I still needed to do more to get back into the environment and do something. So I joined the Climate Reality Project with Al Gore, where you learn to kind of give talks like his. And only a month after that, I did the cover story about climate change and severe weather in the Weekly. A month after that, Superstorm Sandy hit New York City and the East Coast, right? And again, this is a storm that no one ever could have predicted. The waters off the coast of the Northeast were super, super warm compared to normal. And because of that, a superstorm developed. Around this time, as Brooks mentioned, my next project that I worked on was working with Otter 501. And again, they asked me to help write a web version of Otter 501, which is an actual feature, was a movie. And so what I was charged with is taking all the assets and putting them together and having it a web experience that people can actually jump in and explore things about sea otters and how Otter 501 was rehabilitated and what's happening with sea otters. And it's a really great experience. And so I think the experience I had with this and my early experience writing in Ushuaia about my time in Antarctica, and also my 2 books with space were super multimedia as well, really prepared me well for what was coming next. So I finished work with C Studios. We finished our project, but I really needed I rewatched this film, Midnight in Paris. And if you guys haven't seen it, I'd see it for sure. It's a great film. But basically in this film, it was all the writers and the dancers and the artists were in Paris writing about Paris. And this is what struck me. And I'm like, I need to do more. I need to actually get back to Argentina to write this book. And so in only about a month's time, I was already accepted into a residency program, an artist residency program. And a couple months later, I was down in Argentina to write, finally, this whole story that I've been working on for years, right? But what happens basically 2 weeks into my stay is La Plata got hit by one of these 1 in 500 year storms. It's like, you can't make this stuff up, right? So this is La Plata. This is where I was living at the time when this happened. And over 50 people died officially, but they think that it's over 200 probably unofficially died. And you could see, I'm sorry, this is in Spanish in millimeters, but you could see over here, this is a graph. It rained 15 inches in only 24 hours. And in fact, if you look at this one part where I highlight it, in only a 6-hour period, it rained 12 inches. Now, La Plata is a modern planned city. It didn't start out as a village and then go to a town and then a city. It was designed to be a city from the very start. So it had modern infrastructure, but nothing could prepare it for the severe weather that it faced at that time. And all the world is like that. We're getting more and more severe weather. We just don't have the infrastructure to deal with this because we've never had this severity and the frequency of the storms. So again, 51 officially died. I had friends who are pre-med working in the hospitals. They said every morgue in the city was absolutely packed. So returning back to the United States, this is a beautiful photograph. This is the Milky Way, as you can see over here, and this is Garrapatta, and this is the Sabrenas fire. At one point in time, if you guys remember, this was like the worst fire in California history, right? And things have really, really changed. So that was 2016. In early 2017, I joined up with Lawrence Livermore National Lab to work on their science communication. And they have an absolutely amazing climate program there because of some things you probably would never think about. Lawrence Livermore is a national security lab, one of the 3, I guess, national security labs, nuclear security labs. And they deal with things like atomic weapons. They were instrumental in the Manhattan Project. In fact, some of the Manhattan Project scientists actually contributed to early climate work. This model here was done by someone who is an actual Manhattan Project scientist. This is the earliest animation of a climate model. And I wrote a big cover story that covered the national security aspects of climate. They have this climate group and these super great models. They have the fastest supercomputers in the world at Lawrence Livermore, and they use them in all of their atomic weapon research. Before a supercomputer becomes classified, they need to make sure it works properly. In order to make sure it works properly, they use climate models to shake it out, because climate models are very well understood and they're very complex. So think about this. Our nuclear national security uses climate models to make sure the supercomputers work correctly and before they go classified. Think about that, right? That doesn't really get out to the general public very much. So anyway, I did this story about it. And if you look down here in 2017, another piece of the Larsen ice shelf broke off. This is the Larsen Sea. If you've been paying attention to the news, this broke off in 2017. It is almost getting ready to impact South Georgia, one of the islands I talked about. And it's about the size of the whole entire island. So this, over the course of about 3 years, has traveled and is getting ready to hit South Georgia. And that's where Ernest Shackleton did his exploration. So I worked also at the National Ignition Facility, which is the world's largest laser, 3 times the size of a football field. And hundreds of times a year, it creates fusion, which is hotter than the center of the sun. They also use this as the set for the Enterprise in Star Trek. So if you guys have watched Star Trek Into Darkness, you could see the actual parts of this giant laser. You know, I worked on telescopes, and how the great thing about doing some of this communication was how I can connect a telescope to an actual satellite with the advances the lab made. Then I was able to work on a climate satellite with the lab. These are my photographs. Our lab partnered with NASA, and we launched the satellite in 2019. But again, communicating science, right? So I left the lab in 2000 to come back and to focus more on climate, because still, you know, climate isn't the #1 priority of Lawrence Livermore, and I wanted to get involved more. And as I come back to live back in Monterey, obviously we have had all these atrocious fires. And this is funny, I was helping a friend evacuate, and as I'm racing towards the river fire, I passed this little sign, it's Smokey the Bear, and this is the fire danger, was in the orange level when we had that giant fire. It wasn't even in the red level. Think about that, right? And then I caught this photograph, and this guy's shirt read, "The future is on Mars." And let's just hope this is not the case, because if we do a better job of understanding the science and actually putting solutions in place like we know we can, we won't have to live on Mars. And again, we know that as the temperature increases, this is the temperature, right, versus the years, and this is the number of fires. We know that there's a correlation. It makes sense, right? If it's hotter out, things are drier. If things are drier, you're more likely to have a fire. And if you have a fire, it's more likely going to be bigger. And this, I got this from CAL FIRE. This graph shows, it's really interesting, 20 largest fires in California. Now look at this, it's amazing. Only this small section from 1932 to 1999, that's how many of the largest fires in that giant range of time. Then you go from 2000 to 2019, and half of them, right, are in this range. But 1 year alone, look at, it's almost half the fires in 1 year alone of the biggest, largest fires ever in California. It's a trend, right? That is not natural, that is not periodic, that is a trend that needs to be properly addressed. So what I did was I figured that you guys are listening to me. I'm probably preaching to the choir here, right? You guys are not really the problem, because you wouldn't have a speaker like me talk to you about stuff like this. So how do you connect with a wider audience to make them care? And a lot of the time, it's not trying to get through their head, it's getting to their heart, right? This is what the arts are so really good at doing, and this is why I chose fiction. So I basically wrote the novel version of all the stuff I told you, and I made it into episodes. Each episode takes place at one of the locations I was at. But one of the other things that I did is I created this multimedia travel companion. So as you're reading along, just like Otter 501, you could see all that multimedia. You could actually see the real things that are happening in a work of fiction. So I actually have fiction on one side of the book, but on the multimedia travel companion, it's actually nonfiction. It's like a documentary. So you can go to this free website, and as you're reading along, this is the book, say, oh wow, I see these photographs. I want to see what Dan was talking about. I also have an index. You can see if you want to see any of the types of species that I was involved with. You just click that, and all of a sudden you see this. You see the animal. This is a king penguin chick. It's called an oakum boy. Probably not many of you have ever seen a penguin that looks like that, but the king penguin is the second largest species there is. So there's songs, for example. So you can actually hear the songs by just clicking on that, and you can see what the songs I was talking about. I've got a lot of video. I wasn't there to shoot video in Antarctica, and my camera was really not really well equipped to do video, but some of the video the content is really good. Just the video quality, it was shot in SD, and we're not, we've advanced so far, it looks crappy, but relatively, back then it was, pretty good. So you could see something like, some of my favorite videos are like these penguins stealing rocks. Then you could actually track whales, all kinds of other things you could do. iNaturalist, if you guys have ever used that, all connect to this. So you could see how all the species I talked about in the novel are connected. And again, the maps. And the last thing is I put a trailer together so people can actually see it in a nice kind of exciting way. David had put the links out, so if you guys want to see anything else, if you want to try to get the series or look at any other information, there's a list of links that were sent out that you guys could check out and find out more. And if you're interested in me actually giving a real climate talk or other type of talk, please feel free to ask. So with that, I'll open it up to questions.
Excellent presentation, Dan. I really appreciate it. Quick question for you is what nationality were those ships that grounded?
Let's see. Okay, so the one that ran into Deception Island was Norwegian, actually. And the problem with that one is the Norwegians are really good sailors. And so it's kind of surprising that a rock in the middle of Deception Island, which is a famous rock, and there's shipwrecks on like one side of it. Everybody knows it. An experienced captain still struck charted rocks that everybody knows about, right? And the other one, I don't know. I don't know its actual who owns it, but there's a certain set of ships down there that will go back and forth on various tours. And so not every company, is super environmentally connected, and there's an awful lot. In fact, there's a lot of Russian icebreakers, because with the breakup of the Soviet Union, they had a lot of all these surplus icebreakers. And so they were actually repurposed, to go to Antarctica for tours. And that was really kind of, some people attribute that to a major turning point in Antarctica tourism, because it now had ships, that could get there relatively safely. But still, you hit an iceberg, a big enough iceberg, that's a problem. The other thing too is it's the roughest water in the world. If you got an iceberg, there's no way a radar is going to pick it up, So it's still dangerous, right? Because you could strike an iceberg and never see it still.
Is there any efforts to get more intergovernmental control of the Antarctica?
Are you talking about tourism or in general?
In general, so that we don't get everything trashed.
Yeah, so there are some very important treaties for Antarctica, but like anything else, they start off very good and scientific. There's still a lot of science that is, related to national security. There's reasons why, the National Science Foundation put some money in there. We learn a lot about, for example, here's an example. We learned, I think, one of the ways we learned to communicate with submarines, in this era of ballistic missiles submarines is learning about the ozone layer, right? And how radio waves bounced off of different layers, right? So there's an awful lot of research that goes on there still. So they have protections on there, but the problem is it's so far out of sight and out of mind. And, it's hard to regulate and police just off the shore here. Think about that. And we're a little bit better with law and order than some countries. So some, countries don't care at all on any of that stuff. So it's tough. What do they do? So, every once in a while you hear that some ships will catch illegal fishing vessels and confiscate the vessel and scuttle it, but it's very few and far between. It could definitely use improvement. The tourism has a tourism board that is much more progressive and getting better, I think, all the time, because they really understand that if they don't protect it and these accidents happen, it's going to stop, right? And so there's a lot of good people who open up Antarctica for tourism in a very positive way. But like that said, we all experience with how tourism could be horrible when it's not done properly, and resources just get annihilated by over tourism, and we certainly don't want that.
Dan, I was just curious. We do a lot of watershed education with the Carmel River Watershed Conservancy. Do you have some high schools or colleges, especially community colleges, using your online programs as part of their curriculum?
No, because I talk to a lot of high schools and schools, and but I don't have it set up as a standalone program. It's more so that if someone wants to talk about climate change, I've lectured at CSUMB a ton of times, both on climate and actually plastic pollution. I was involved with NOAA and Surfrider. We had a big community outreach program for plastic pollution, and so things I do are kind of like mostly one-offs. As I'm just kind of an independent freelancer. I'm not really connected to any type of university or anything like that, which has positives and drawbacks. I don't have any specific curriculum as such. I work in education. I'm familiar with what you're talking about. I actually developed a curriculum for a physics thing I did for LA Unified School District. They had me do something specific, but no one has really asked me to do anything specific for a school other than just talk. Mm-hmm. I gave a talk to preschoolers. So I had which is an interesting thing. So this is earlier this year before COVID broke out, at least before we knew COVID broke out. They had me come in, and the teacher was doing a unit on environmental heroes. And so she knew my work. She actually was a beta reader for the novel, and she got really inspired. And this is like the perfect person, because, based upon her reading it, she got really involved in climate and activism, and it did exactly what I was hoping for. And she eventually invited me to her classroom. So how do you talk to preschoolers about an issue like this? Obviously, you can't get into these scientific things that we're talking about. But what you can do is show a bunch of photographs of penguins, some of the funny things they're doing, where they're living, and at the very end, you say, if you like penguins, we just have to protect where they live. And that's the only message that you really need to give preschoolers in that particular audience, and they get it at that level, right? I've kind of done the whole gamut from, lecturing at Stanford. I've talking to the students there, So it just really depends upon, who's asking.
Okay, thanks.
Dan, thanks a lot for really interesting material. In your experience, what kind of messaging actually delivers to people something they can take with them on an individual basis to actually influence the course of climate change?
Boy, there's not one simple answer. And I think I've approached it as, I think what we need is a diversity of tactics. Because what I say about climate change is whatever we're doing is not sufficiently worked. Because the science, everything that we need to know in order to do the right thing, we've known for decades. The only thing we're learning now are deeper and deeper details, right? So why has it been such a problem? And really, it's been one of communication. We are not doing a good enough job to reach people in order to stir them enough, or in order to influence politicians enough that they're willing to take the hit and say, you know what, I know it's going to be unpopular with the people, but it's for the best, right? We just have not been able to do that. And so what I've tried to do is that everything kind of connects to people different. We just need more avenues and pathways for reaching people. That's part of the reason why I did that one climate change story with the models, the nuclear models, right? I basically linked climate with about the toughest national security thing you could possibly do, which is nuclear weapons. So I've reached a group over there that's like, oh, national security is important, national security is important, nothing else matters. Climate change can't possibly be true. But I showed that by linking that one story. Then for a different audience, again, this book, I do some work with Climate Reality Project, and that's Al Gore's thing. And a few years ago, they had a speaker there who was a policy person from Berkeley about climate. And she had been like a dozen of the conference of the parties for climate change. That's the Paris Agreement talks, right? And I spoke with her afterwards, and she's like, we don't need more policy. We just need Angelina Jolie making a movie about climate change. Now, she really wasn't saying that we don't need more policy, because we certainly do. But it's like the choir, right? How do you reach more seats? We want to get more people in the church sitting down. We just don't want to keep talking to the people in the choir. And there's really not one single way of doing it. It's going to require a multitude of ways to do it. And that's really what I believe is it's a communication problem. We have people calling COVID a hoax, and we have somehow gotten so off balance where people at the highest levels of our government are just dismissing really important scientific facts, right? It's communication, right? Because they're reaching people through communicative channels, whether it's Facebook, whether it's this or that. And there is the fundamental problem, really, is we've got this really big communication problem, and we need to solve it, because we can't just choose whatever facts we want, whatever we want the facts to be, even when they're wrong, to serve our purpose. It doesn't help anybody in the long run.
I was just curious, are you able to reach out to the new administration to help educate Congress on any of these issues? I think they're so well put and understandable. And I think there's some opportunities there maybe to educate Congress and some of the people higher up in the administration.
Yeah, I did apply to the new administration. But I'm not an insider ultimately, and I think there's opportunities, but it's whether they utilize.
Reach out to John Kerry directly, given his new role.
Can I piggyback on that?
The question
I had, and I actually do climate change and national security work.
Oh,
so
great.
Thank you so much for your talk. I was learning things and also nodding my head crazily. So, but I heard John Kerry and of course now Gina McCarthy will be hit with this as well, but they're getting questions about, rejoining the Paris Agreement, which Biden has committed to. But beyond that, they questioned John Kerry about a week ago about, does the Paris Agreement go far enough? And he acknowledged that it doesn't.
No.
There are absolutely improvements that can be made to that. But then the question came up of, well, is this going to be a sacrifice to the American people? And so how do you talk to people about making changes, especially in the midst of massive unemployment and, we're just dying to emerge out of this pandemic and go back to normal. But what are the communication strategies to talk to people about sacrifice, which there's going to be some, but what they're going to get in the long run? So I just wondered if you had worked on that at all.
Yeah, I have. And it's and again, it's pivotal to the work that I do. Let's just think, for example, of the fires, our recent fires, right? Look at the economic damage that those fires caused, right? People were shuttered in. Do you know the agriculture was impacted? It affected planting. There is and the other thing too, to fight those fires, it's an extreme amount of money. That money is coming from somewhere. I know people whose house payments, their insurance have doubled. Right? There is an absolute cost we are paying, and the matter of fact is, it's the population, it's the public that are actually already sacrificing it. We just don't see it quite so much because it's not so directly apparent. But think about this: if the federal government and state government have to pay all this stuff, that money is coming from somewhere. It's coming from the money that we put in as taxpayers. So that means other services are going to be cut, right? There's no way you can't pay for everything. When COVID, the amount of money we're paying for COVID, which also we know that things like infectious diseases are exacerbated also by climate, and that's scientifically proven, right? So this is not like just, throwing everything in, but there is such a giant cost to things. And it is part of the communication for people to see these costs. But the problem is, people are really usually super willing to throw in a couple dollars to help, people from a fire, to help, when there's a hurricane. Oh, there's hurricane relief, people chip in and all that stuff like that. There's all these good feelings about chipping in when these disasters happen. But you know what? I've been fortunate to actually not lost my house or lost anybody. But I tell you, I would rather not have those disasters happen in the first place. And the people who are receiving this generosity would probably also tell you they would rather not have lost their houses, right? So how do we communicate that? How do we say, you know what, we can't just wait till it's your turn that your house burns down or a flood event happens, right? There's a cost, right? And it's making those connections to people that is really what we do not do well enough. It's just not done. The other thing is just the wording. If I hear the word existential connected to climate change one more time, I'm going to pull my hair out. They even use that word, Biden is using it because it's a buzzword. The people that we're trying to connect with, how are they ever going to connect with a word like existential? What is an existential crisis? You're using vocabulary in a way that drives people away. They don't get it. That is not the way to communicate it, And so the work that I do, this talk was at a higher level because of the audience that I spoke with. But I certainly would not choose to show and go over the things that I did with different audiences. And so again, communication-wise, if our leaders aren't getting if our leaders are trying to do the good thing, but our politicians are not science experts and they're not expert science communicators, and the people that they're getting under them are also not necessarily great science communicators, right? How do we change that conversation? And that's really, I think, is the key. Otherwise, we don't need more science. We do not need any more actual climate science studying because we know the problem, So Yeah, it's communication, you know.
Thank you.
From working on, again, superconductors and, going to poems and going to a novel and, sex sells, think about these things. These are the things that, the marketing strategies that are selling ridiculous stuff. We need to do better at implementing that to help get climate connected to people, in ways that work, that are effective,
Well, I thought it was great. I'll give you a short one. I have a friend who was a meteorologist and spent the whole life on weather. He truly believes that that there is no such thing as global warming caused by man. My only argument I can make to him is that if I'm right and there is a problem and we spend money to resolve it, we will have spent some money. We will have, if he's right and we follow my course, we will have spent some money we didn't need to. If I'm right and he's wrong and we follow his path, it's disaster.
Sure.
It isn't just a little bit of money. It's the world goes away.
Yeah.
And it's, by the way, it's the same thing with COVID. If I'm wrong, I'm uncomfortable under a mask. But if the other guy's wrong, we lose 1 million people to death in a year.
Well, you bring up a point, like there's an interesting connection between meteorologists. A lot of times you'll have heard in the past that meteorologists have been these people who have kind of been against the climate. Now, meteorology, weather, is short term, right? So you can't, weather is like, oh, can you tell me if tomorrow at 12 o'clock noon it's going to rain? We can't tell you that very carefully. But climate, we are very, very good at predicting climate, because climate is about averages. And so what you can do with climate is really, really, really precise. And the thing is, I think it seems every month you hear of another weatherman or another meteorologist saying, I didn't believe in climate change, now I do, I don't really know what to say to that. It's just that there are going to be people who will not look at all the facts, and they'll be, looking with blinders, whether it's for political reasons, economic reasons, other reasons. There'll be a lot of factors, but again, that's what the communication is. How do you communicate to someone who is obviously knows a heck of a lot about precipitation and clouds and all that stuff? How do you connect with a person like that? But just going, also one last thing is the national security issue on this thing. Do you know that we've had, climate is a very serious national security issue. In fact, Janet Napolitano used to be the head of Department of Homeland Security, right? When I was at the lab, she came to my lab to do a presentation, a town hall meeting with the lab director, right? And so mind you, Lawrence Livermore is a square mile complex, and it is, the stuff that happens there is just mind blowing. And if there are flying saucers from other planets, they probably got them there in some room, type of thing, right? I've literally worked on crazy stuff. But she was asked in this national security lab, for example, even weapons of mass destruction, when we heard just recently, I guess the Syrians using chemical weapons, it was our lab that went to investigate that. We had our scientists go out. She was asked in front of the whole group, what does she think the biggest threats to our national security are? And she said, number 1, climate change. Number 2, cybersecurity. Number 3, gun violence. She didn't say the Russians. She didn't say ISIS. She's like, we have a handle on many of these other things. We understand how they work in the dynamic, right? So they're known entities, right? But those 3 are the things that, in her opinion, were the biggest national threats, because they're not handled. We don't know how to handle them. We're not doing it, And I thought that was really interesting. because, you know, ISIS, for example, you know, when you have a drought for years and years and years in the Middle East, and all of a sudden all these people can't farm and live, and when they go to the city, they have to survive somehow, and they are ripe for radicalization, right? So that's a climate crisis. That's national security, right? When you lose, you know, where you're living because of, like, you know, flooding that keeps putting seawater in and kills all your crops, those people move somewhere else, right? These are national security issues, right? There's no doubt about it. So it's a hugely important, you know, subject.
Well, as an engineer, your first few charts just, I thought they explained climate change like I've never seen it explained before, and I'm going to be looking at those.
Great.
Brooks, why don't you come on and say goodbye?
Yeah, well, thank you again, Dan. That was a thoroughly engaging and challenging presentation, which I'm sure from the questions, you know, everybody enjoyed. Again, I want to wish everyone a safe and joyful holiday season.
Thank you again.
Same from us.
Happy holidays, everyone.